Okay, so today we're going to look at the proof of the Pythagorean theorem. So we know what the theorem says. We know that it says a squared plus b squared equals c squared. But assume we didn't know this. So I'm going to say we don't know this. Okay? And now, how would we come to this conclusion? What do we have to do to come to this conclusion? Well, as you can see, I've drawn two squares here, okay? So assume, I know these might look like rectangles, but they're actually squares. So this side right here, so this is a smaller square inside a bigger square, okay? So the smaller square, let's call this length right here C, okay? That means since it's a square, all the side lengths are going to be C. Okay, and the bigger square, I made it in such a way so that this length here is a bit shorter than this length. So this is A, let's call it length A, and let's call this length B. And then this length right here is the same as this length right here, so I'm going to call this A. And then this length right here is the same as this length right here, so I'm going to call it B. And then it's just alternate, so it becomes A, B, A, B, A, B, and then A, B, okay? So that's the way I've made this square so far. So far I haven't done anything. I've just made two squares. I've divided the big square in such a way so that I have A plus B on the top. So I have A plus B and then I have A plus B. So you can see it's still a square, right? Because this length right here is A plus B and the other length is also A plus B. So it's still a square. Now I want to find a few things. I want to find the area of the big square. So how would I do that? Well, that's pretty simple, right? The area of the big square is just going to be A plus B times A plus B. So that's A plus B times A plus B. And what does that give you? That gives you A squared plus B squared plus 2AB. That's what the area of the big square is. You can use FOIL and you can expand it out and you'll end up getting this. Now what's the area of the small square? Well, this is even simpler, right? Because the small square just has the length C. So the area for a square is just going to be C times C, which is C squared. So I have C times C, which is C squared. Okay, so I have the area of the big square is A squared plus B squared plus 2AB. And the area of the small square is just C squared. Okay, well, A, B, and C are just some random numbers, okay? Now, what do? Well, let's say I want to find now the area of this triangle. So you can see these are right angle triangles, right? This is a right angle triangle. This is the right angle triangle. This is a right angle triangle. And this is also a right angle triangle, of course, right? Well, we know how to find the area of the triangles, right? The area of the triangles is going to be half base height. And you can see these are all the same size. All these triangles are the same size because they have both have the lengths A and B. So the area of the triangle is going to be A times B divided by 2. Okay, so far so good. And now how many triangles do I have? I have 1, 2, 3, 4 triangles, right? So the area of all triangles, is going to be 4 times A times B over 2. So it's going to be 4 times AB over 2, which is actually equal to 2 times AB. Okay, so far so good. Now what am I trying to get at? Okay, so I have the area of the big square, I have the area of the small square, I have the area of the smaller triangle, and I have the area of all 4 triangles. What do we do now? Well, I know, right, that to get the area of these 4 triangles that I got 2AB, what I can also do is I can take the area of the big square and then subtract the area of the small square, because that's actually what's going to end up giving you this remaining area of this triangle, this triangle, this triangle, and this triangle. So that means that this area right here, 2AB, is actually equal to the area of the big square minus the area of the small square. So that's equal to A squared plus B squared plus 2AB minus C squared. Okay, now what can we do? Well, if we subtract 2AB from both sides, we're going to get 2AB minus 2AB is equal to A squared plus B squared plus 2AB minus C squared minus 2AB. Okay, well, this will cancel out. And this will also cancel out, right? Because 2AB minus 2AB is 0. And then 2AB minus 2AB here is 0. So I'm left with 0 on this side is equal to A squared plus B squared minus C squared. Well, now you can see that you have the formula. Now I just bring the C squared to the other side. And I'm left with C squared is equal to A squared plus B squared. And then I can rewrite this in the way that we know. We get A squared plus B squared is equal to C squared. And that's the theorem that we wanted to prove. So, how did we get there? We had a bigger square with a side length of A plus B, and then we had a smaller square inside with a side length of C. We found the area of the big square to be A squared plus B squared plus 2AB. We found the area of the small square to just be C squared. We realized that the area of one of these triangles here is going to be AB over 2, so the area of all these 4 triangles is going to be 4 times AB over 2, which is 2AB. But then we also realized that that area that we get from the 4 triangles is the same as the area of the big square minus the area of the small squared. And once we do that and do some rearranging with some algebra, we end up getting a squared plus b squared is equal to c squared. So yeah, that's the most common and famous proof of the Pythagorean theorem. There are, of course, many proofs of this. And if you have one, please leave a link to it in the description. And yeah, if you like the video, please like, share, comment, subscribe. Let me know what else you want to see in future videos.